You bend this metal and it stays bent, nothing springs back. It looks permanently damaged. And then you warm it slightly and it snaps back to its original shape, as if nothing ever happened. That feels impossible. Metals don't remember shapes. What we'll see here is why this happens, why strength is not the reason, and how geometry quietly does all the work. In an ordinary metal, bending forces atoms to slide past each other and stay there. The metal has no preferred shape to return to, so the bend becomes permanent. But shape memory alloys behave differently. Inside them, atoms are arranged in a pattern that can exist in two organized forms. At lower temperatures, that pattern is folded into a less symmetric layout. When you bend the metal, you're not breaking the structure, you're simply rearranging that internal pattern into a different allowed configuration. Think of a folded paper spring. You can squash it flat without tearing it because the folds are designed to move. But no matter how you squash it, those folds still exist. When you let go, the paper doesn't push back because it's strong. It returns because the folds only fit properly in one shape. Shape memory alloys work the same way. They give way easily, but they never forget the internal arrangement that defines their original form. When the alloy is warmed, atoms gain just enough motion to reorganize. The internal pattern switches back to its more symmetric form. As it does, the metal is forced to move into the only shape that fits that pattern. Engineers call this process martensitic transformation. That sounds complex, but the idea is simple. The metal changes shape by rearranging its internal geometry, not by stretching like a spring or flowing like a liquid. This only works within allowable pathways. If you bend the alloy too far, cut it, or force it into a shape that the internal geometry cannot support, the effect just disappears. The metal doesn't fail because it's weak, it fails because the geometry has run out of options. Strength was never the hero here, structure was. This is why shape memory alloys are used today in medical stents, temperature-activated switches, and compact actuators. They move reliably without motors, gears, or electronics, because once the temperature changes, geometry leaves them no other choice. Shape memory alloys don't return to shape because they're strong. They return because their internal geometry makes every other shape unstable.